right, let's look at number 10 from our SOA practice P exam problems. So I encourage you to try this problem first, hit pause, and then only come back to look at the solution after you've tried it yourself. So an actuary studying the insurance preferences of automobile owners makes the following conclusions. An automobile owner is twice as likely to purchase collision coverage as disability. So let's write down what that is. The probability that you purchase collision coverage is twice as likely that you would purchase disability coverage. So P of CC is equal to twice P of DC. So that's going to be DC here, and this is going to be CC. The event that an automobile owner purchased collision coverage is independent of the event that she purchases disability. So we know then that the product of their intersection is equal to, the probability of their intersection is equal to the product of their probabilities. That's what we get from independence. And we also get all the respective complements as well. So the probability of not CC and not DC is equal to the probability of not CC times the probability of not DC. So we get that as well. All the events in their complements thus are independent. All right, then we're given that the probability that an automobile owner purchased both collision and disability, so that's this right here, the probability of CC intersect DC is 0.15. Okay, with these two alone, we see we can compute both P of CC and P of DC. What's the actual question asking? Calculate the probability that an automobile owner purchases neither CC or disability coverage. And that's this one. So we're looking for the probability of not CC and not DC, which we know is going to be this product, which is going to be 1 minus P of CC times 1 minus P of DC. So we're just left with figuring out P of CC and P of DC. So let's come down here and write our two equations down one more time. P of CC is equal to twice P of DC, and P of CC times P of DC is equal to 0.15. So I'm going to replace P of CC in the second equation with this. So I have 2 times P of DC times P of DC, again, is equal to 0.15. Or P of DC squared is equal to 0.075. Now let's put that in parentheses. Taking the square root of both sides, you get the probability of DC is equal to 0.27386 and so on. So we'll just say 9 right there. This means 1 minus that is equal to, so 1 minus 0.2739 is equal to 0.7261. Okay, so that is P of not DC. All right, so we know one piece of this right here. That's going to be 0.7261. We now got to find not CC. So we're going to use this and that. So P of CC, let's see what we have here, is equal to 2 times 0.2739. And that is 0.5477 and some change, which means 1 minus that, 0.5477, is 0.4522, and that is the probability of not CC. So using this and this, so that's going to come back up here, 0.4522, multiplying that, so let's come over here to our calculator, 7261, we get 0.328 and some change. We go look at our answer choices, and we see our answer is B.